Jai Hind. Today we are going to discuss the concept of linked list. In particular topic, we'll talk about what is linked list, what are different types of linked list, and then we will consider singly linked list. In this particular lecture, we'll talk about three particular operations: traversal, insertion, and deletion. So let us start with the topic. Linked list. What is a linked list? In linked list, we store data in linear relationship form. So it is a linear data structure that contains a sequence of elements such that each element links to its next element in the sequence. So we are having a sequence, we are having the storage of element in sequence. If we take the example of arrays, in arrays also we take a sequence of elements, we store that in linear fashion. And how do we store that? Those are stored in contiguous locations in memory. In linked list also we consider in linked list is also linear data structure. It stores a set of elements, a sequence of elements, but now the storage is not contiguous in memory locations. So what we have first node stored at one point, then somewhere we are having the second node, and somewhere the third node. Then how do we access? If we talk about arrays, in arrays we access the elements with help of the subscript, because those are stored in contiguous location. But in linked list, these values are stored at different locations through nodes. And how do we access different elements? We access through first node. We are having address of first node, and the first node is having address of second node, where the second node is stored, which is having the second element. Then that will contain the next node address, and so on. So what is there? Each element links to its next element in the sequence. Arrays are generally used when we are having in advanced knowledge of how many elements we are going to store. But where linked lists are useful, when we have to work with unknown number of data values. We are not aware initially that we are going to store 10 values, 20 or 100 values. So according to that, during runtime, we decide that how much memory is required. So it uses dynamic memory allocation. So we decide whenever we get some data, we create a node and store that element in that particular memory area that we have allocated during the runtime. We are having different types of linked list: simply linked list, or this which we call single linked list, doubly linked list, or circular linked list. So when we have simple linked list or singly linked list, what we have at a particular node the address of the next node, at second node the address of third node, and so on. And we are able to traverse the linked list in forward direction till the end. The last node will have the null point, the pointer value null, because that is the last node and it is not containing any next node address. In doubly linked list, what we have, we take two pointers, one in forward direction like singly or simple linked list, and one in backward direction. So we are able to navigate forward as well as backward. It means from first node to last, as well as from last node to first node. Both direction traversal is possible in doubly linked list. Next is circular linked list. In circular linked list, we have the storing in circular circular fashion. So in this, what happens? The last item contains the least link of the first element as next, and the first element has linked to the last element as previous when we are taking the doubly linked list. If it is single, then the first node will contain the address of second, and the last node will contain the address of the first node. So these are different types of linked list that we can have. Now we will start with basic one. We will understand the linked list concept, the different operations, in particular insertion, deletion and traversal for simple linked list, single linked list, in which the navigation, the traversing is in forward direction. So this is our singly linked list. If we see this, the singly linked list contains nodes. This is first node. Whatever we are having, if we take the example of arrays, for arrays we have the base address of the array. In linked list, what we have the address of first node. First node we can call the head node or first node or start node, whatever we take it. So here we are taking the head node. So we will have nodes. For example, in this particular, this is first node, second node, third node, and this is last node. What is the identification of last node? The last node is having the pointer value null. It means there are no further nodes. But what is the property of linked list? If we have more nodes, we can create and link with this set of nodes. These nodes are connected through links. We are having information of first node. So like arrays, linked list is a linear data structure. Unlike arrays, linked list elements are not stored at contiguous location. These are linked using pointers. So we are storing values in sequence, but these are linked through pointers. First one is having address of second node, second is having address of third node, and so on. So when we need to search something, we are not now using subscript like arrays, we will use these links. So when we have to create something like this in memory, it means I should have this user-defined data type according to our storage requirement. So if we consider that we have to store an int value, so it means we have to store sequence, a set of integers, as like we store in arrays. In arrays, we simply declare int a10 if we take example of C. Now what we will have here, we will have to create a structured data type. Why we need to create a structured data type? Because every data is stored in a single node, and that node is having address of the second node, next node. So if I consider this particular, in this, I'm having a data portion which I'm taking here character A. So now let me take my requirement is of integer. So it will be int data. Int data will have some integer value in data portion. And second is self-referential pointer. What does it mean? It means if with this data, we have to store an address. Address of what? Address of a node. What type of node? The same type of which we are having in structure. So struct node star next, the same type of point. We are taking a pointer which is pointing to same type of data. So we call it self-referential pointer. Why we are taking? Because we are having the address of same type of node at some other location in memory. So this is the structure that we are going to use. Now it depends on that what type of values you are storing. So if I take it single character, so I will take here char data. If I am having some names, so I can say char name 20. So it depends on what type of data we are storing in our nodes. Now we'll discuss what operation we can perform on this single linked list, singly linked list. So we can create single linked list when it is not existing, so head node is null. If it is existing and we are inserting something, means we want to expand, we want to store one more value, or we want to delete something, or we want to go through all the nodes. For example, I want to display the data which is stored in linked list, or I want to search some data, it is stored in linked list or not. I want to display the data in a complete linked list. Searching, we talked about concatenation. We want to concatenate two linked lists. These are different requirements that we can have. So according to that, we are having different operations on singly linked list or simple or single linked list. So now let us start with the operation. So firstly, I am taking the traversal operation. Then we'll talk about insertion and deletion. So in this particular traversing, what I'm doing, I have to find out something. So I will traverse the linked list. How to traverse the linked list? In arrays, we directly take subscript, but here what we will have the address of first node. So but after traversing this, how I will go to next node with help of this pointer. Then I will process this. Then I'll go to third node with help of this pointer. Then I will process this node, and finally I'll go to the last node with this pointer. Now how I can recognize this is last node? That we will see the null pointer. The pointer value is null. It means this is the last node. There is no more node left in this particular linked list. Okay, so here we'll discuss one function to traverse. Why we are traversing? We are trying to find the data. So what we have taken here, the search algorithm to understand the traversing. So struct node star head. What is my first argument? My first argument is the start node address, that is head pointer of the linked list. It means I am having the address of first node, that is my starting node. So in this we have sequential access. In arrays we have random access. We can use the subscript and go to that location. In this we will have the sequential access. So bool search, it will return true or false. So I have taken boolean. Search is my function name. Struct node star head, and what I am searching in this list, which is having the first node address in head pointer, that is int x. Okay. So now what we will have, we will traverse through the complete linked list. So for this we are taking a pointer that will tell us what is our current node. Okay, so temporarily here we have taken a pointer current, which is having the address of first node, that is head. So currently I am here. My current pointer is pointing to this particular node. Now we will go on searching until we go through the linked list and we reach to the null, that is out of the linked list. Okay, so what we will do, while current is not equal to null, it means we'll go through the complete linked list until it exhausts. Now, if current data is equal to x, current is this pointer. At this pointer, what is stored? Two values. First is data and second is the link to the next node with help that name is next. Okay, so we will check the data. If we got the data here, so I'll compare it with the data. If I got the data, then I will return true. Otherwise, current is equal to current next. It means current will take the value which is stored at the next pointer of current. So current of next is having address of this. So what will happen now? Current will will point to the second node. Now again it will compare the data stored at second node. If match is okay, otherwise current will become current next. It means the pointer value which is stored in the next pointer of this, that will take, so current will point to this. So we go on accessing the data and comparing. So I'm traversing through the linked list. I'm searching an element. Okay, so how I'm moving from one node to another, I'm taking some temporary pointer which I'm calling here current. In current, I'm storing current next. So we are going to the next pointer and next node and so on until either we are getting the data or the linked list has been exhausted. So this is our traversing through different nodes of linked list, and it is always sequential in nature. One by one we will visit. Firstly, we'll go to first node, then we'll go to second node, third node, and so on. So this is our traversal. Now we'll talk about insertion. So here on this particular slide, we'll talk about at the front of linked list. It means I'm already having a linked list. So when I'm having a linked list, let me consider a linked list with two nodes. So I'm having this linked list. In this something is stored. Let me say it is storing 10 or A, whatever you take. And then if I take another node, the address of this node is stored here, and I'm taking its second node. So let me call it as the last node because I have taken two nodes. Now what I'm going to do, I have to insert at the front of this linked list. Okay, so I have to insert some value. Let me say I have to insert 5. So firstly, I have to insert 5. It means I need memory where 5 will be stored. Now, what type of memory? What is the way to store in linked list? The way to store is node. Whatever you will store in linked list, that will be a node. So what does it mean? It means I need to create a node. How a node is created? How will I create a node? I will allocate memory. Okay, so let me allocate some memory. Okay, so I allocated memory. That is my first step. Allocate data. Allocate node. Okay, so memory is allocated. So a node has been created. Put in the data. What I wanted to store? 5. Where do we store? In first part. First part is data. Second part is pointer to the next node. Okay, so this is data and this is next pointer. These two things have been created in memory. So what I'll store in data? I'll store in data of the new node created, that is 5. Okay, that is my second step. Put in the data. Now the point is, what I have to do? I have to put this at the front of the linked list. Okay, so front of the linked list means something in the front. So whatever front was, that will become the second node. So how to make that second node? We will make next of new node as head. This was my head. Okay, so what will be made the next of new node? That is head. So what does it mean? It is pointing to head. This was our head node. Now in next of the new node, I have given this address. Now this has been linked to this. Now we can change the head node. Now I'll take head as new node. Move the head to point to the new node. So we can see here, now this is our head node. This is first node. This is second node. This is third node and so on. So we have done insertion at the front of the linked list. So now let us go through this. My function is insert at beginning. I'm changing the node. Which node? Head node. It means to reflect the changes, I need the reference to the head node. This is my reference to the head node. The new data that I want to put in the linked list. So firstly, a new node has been created. How to create? Using malloc function. How much memory will be allocated? According to size of struct node. So memory has been allocated, and because it is returning void type, so to make it to point to struct node start, we are doing the typecasting. Okay, now node has been created and its address is in new node pointer. Now what we said, new data will be put in the new node. So new node data is new data that we have to store. We have sent in the function, and What will be pointer? Pointer will point to the head reference, head node. Okay, so it is star head reference. So what is done? We have created a node and it is containing data as well as pointer to the previous head node. Now we have made the head node second, so our head reference will be changed. Now the new node will become the head node. So we have inserted a node at the start of existing linked list. So first node has been changed. This is insertion at the front. Now let us understand one more thing, that is insertion at the end of linked list. Again, we are given some linked list. Let me say this is my linked list. This is the head node. It is having some data, then some second node. Now, as I have to insert node at end, it means I need to traverse. For example, we have already traversed in during searching. Okay, so first I have to insert. Let me say I'm inserting 5 now at end. So what is the first thing? Allocate node. So let me allocate node using malloc function as we have done on the previous slide. Put in the data. I put in the data. This new node is going to be the last node. So its next pointer will be null because it is going to be last node. Now what is required? Now I have to insert address of this node, which is my new node, in this pointer, which was previously null because it is the last node and I have to insert at end. So what we will do, if the linked list is empty, then make the new node as head. It means list is not there. So the only node is the new node. So head will also point to this. But else we will traverse till the last node. So for this, we will use some pointer that will be stored head value. Then we'll go to, let me say current or last, whatever we want to take. So current, then current will be current next. So it will come to this. Till which point we are going to do this? We have to check, is the current next is null? If current next is null, we have to stop here. And in current next, what we will insert? The new node, which we have created, and we have initialized both the values, the data as well as the next pointer. So what we will have? We will create a new node and same malloc function, a new node has been allocated. We have taken a pointer which will talk about last node. Initially, we are taking the first node address as the last node address. That is for traversing through the list and reaching to the last. Now, new node data has been created. In new node data, we will enter our data and its next pointer will be null, as we discussed on the last slide, that as it will be the last node, it will contain null pointer. Okay. Now, if this is there was no node initially, so in that case, head ref will be null. So head ref will become new node, and we will get a linked list with just one node, which we have just inserted. And if it is not there, if we are having a non-empty linked list, then what will be there? We will go to the last node by traversing. So while last next is not equal to null, last will become last next. It means we'll take the first node, then pointer of that, and we'll go to second node, third node, and we have to go to the last node. How we will identify the last node? Last next will be null. So we'll stop here. Okay. And now we have gone to that node in which last next is null. Now we have created a new node. Now that null will not remain null any longer because it will contain address of the newly created node. Okay, so last next will be new node. So we have inserted at the end. This is insertion at the end of the linked list. Now we'll talk about deletion. In deletion, we will take a key which we have to delete. So this is our delete function. In delete function, again, we are taking headref because it may be the case that we have to delete the first node. And if we have to delete the first node, it may be the case that headref may get changed. Okay, so what we are having here, the first node address and the key value to be deleted. So what we will have, we will go through the complete linked list. Either we will get that value in the linked list or it will come to an end if the key is not present. Okay, so what we will do, headref will be taken as temp next. What I have taken in temp is pointing to the first node. Temp pointer is pointing to the first node. So if temp is not equal to null and temp data is key, what does it mean? It means the head is having the key value. If head is having the key value, then what is getting deleted? The head itself. Okay, and what will be head now? The second node. So head ref will be temp next. It means the head will point to second node and head address is contained in temp. So that node will be free. Memory will be set free. So we have deleted the first node. If it is not at first, then what we will do? We will go on searching the temp data. In this, what we have done, we have checked the first node. Temp is null or not. But when it is not there, then we will search through the complete linked list. And while temp is not equal to null and temp data is not equal to key, what will be previous? Previous is temp. We are taking care of, keeping track of previous, because when a node will be deleted, its next node will become the next of its previous. Okay, so what we have done here in if condition, we have checked that the key is stored at first node or not. If it is stored at first node, the head is changed. Star headref has become temp next. Now, if it is not at first node, we'll go through each node, we'll traverse the node. So either the list will be exhausted or we will get the key. If we get the key, what we will do? What we will go on doing while we are not getting this situation key, what we will go on doing? The temp on which we are having, that will be taken as previous node and its next will be taken as temp. Means we'll move to next node, but after checking temp is the last node or it is having the same key, either it will be end, or what we will do, we'll jump to the next node and this current node we will store as previous. Okay, so that we are taking here, previous is taking temp and temp is stored as temp next. Okay, so temp next will be now temp. Now if temp is null, it means this while loop has stopped because of the end of linked list. So we'll simply return. Okay, otherwise what is there? Otherwise means we have got a node which is having this particular key value. Okay, so in that case, in the previous PRE, we are having address of previous node. So previous next will be temp next. It means the next of temp will be next of previous. It means the link of temp has been deleted. It is disconnected from the linked list. So simply we will free temp. So in this way, we will delete a node which is having the key value stored. KEY, we are taking the value which is the key value. The node with this key value will be deleted. Another deletion function. in this particular deletion function, a change has been taken. What is the change? Now we are not taking the key value, we are taking the key position. Okay, which position node we have to delete? Okay, so we have taken position. So if head ref is null, it means there is no element in the linked list is empty, we will simply return. Otherwise, we will take a temporary variable. Okay, now if we have to store the first value, then simply head ref will be changed to temp next and temp will be free. It means the first location has been, the first allocated node has been deleted. Otherwise, we will go to that particular location. So for I is equal to 0 to temp not equal to null, it means until the either the list is exhausted or the required position is achieved. What we will go on doing, I plus 1, I will go on incrementing, temp is equal to temp next. It means we'll start from first node, we'll go to next node, until either we get the required position or our linked list is exhausted. So we will go on moving and we will reach finally to the last node. Okay, now if temp is null, means the list has been exhausted, then there is nothing to do. Okay, if temp next is null, temp is null or temp next is null, so no other requirement is there. Now what we will do, we will find out the next pointer. What is the next pointer? It will be, now we have received temp. Okay, so we'll take temp next. We have stopped at temp next is equal to null. So what we will do, we will consider next of temp next and we will free this temp next and temp next will be next. So in this way we will delete the required node. Okay, this is our deletion of a linked list from a given position. Okay, so in this particular lecture we talked about what is linked list, what are different types of linked list, how to traverse through the linked list, what type of access is there, it is having sequential access. Then we talked about the operations, traversal, insertion and deletion. Thank you. Jai Hind.